Hi friends, sorry that I can't be with you today. I have to be at a meeting. I would much rather be in class with you, but I thought I'd record a little bit of a video for you to help you out with today's notes. If you haven't done so already, please pause the video and take some time to see if you can find the next three terms in all the sequences that are listed on the front page. Okay, welcome back. The first thing we're going to talk about is the fact that sequences can be written in two different ways. We can write what's called a recursive rule, and we can write what's called an explicit rule. A recursive rule is a formula for a sequence that defines each term based on the previous term. So for example, if I have the sequence 3, 5, 7, 9, 11, and so on, I can write a rule, a recursive rule for this sequence by saying that the first term, which we call A1, is equal to 3, and then starting with the second term, we can say that the nth term, so any additional term, is equal to the previous term plus 2. Notice that for the second term, this is equal to the first term plus 2, the third term is equal to the second term plus 2, and so on and so forth. An explicit rule is a formula that defines a sequence based on the term number. So you don't need to know any previous terms in order to figure out what an individual term is. So let's go back to that same sequence, 3, 5, 7, 9, and so on. In this case, I can say that the nth term is equal to 3 plus 2 times n minus 1. Or what equivalently, I can say that this is equal to 2n plus 1. Notice that when n is 1, I get 3. When n is 2, I get 5. When n is 3, I get 7, and so on. See if you can go back for the sequences that are listed on this page. See if you can write some recursive rules, and then if you want to try some explicit rules, you can go ahead and do that, but I'll give you a chance to do some more of the explicit rules in just a few minutes. So go ahead and pause the video, see if you can write some recursive rules for some of the sequences listed here. Now I want to talk a little bit about arithmetic sequences and geometric sequences. Arithmetic sequences are sequences that increase or decrease by a constant amount. Each term. We call this D for common difference. You can think of these sequences as either addition or subtraction. So one example of an arithmetic sequence would be the sequence 2, 5, 8, 11, 14, where the common difference in this case is the number 3, because each term is 3 larger than the term that preceded it. Now when we write a recursive rule for an arithmetic sequence, we first write what the first term is, and then we say that starting with the second term, the nth term is equal to the previous term, n minus 1, plus whatever that common difference is. So in this case, if we wanted to write a recursive rule for this sequence, we would say the first term is 2, and then starting with the second term, any term is equal to the term prior to it plus 3. Notice this will give us every term in the sequence. The first term is 2, then when n is 2, we say that a sub 2 is equal to a sub 1 plus 3. That gives us 2 plus 3, which is 5. And then when n is 3, that's equal to a sub n minus 1, which is a sub 2, which is 5, plus 3 is 8, and so on and so forth. Now if we want to write an explicit rule for an arithmetic sequence, we say that a sub n is equal to the first term plus the common difference times n minus 1. So for example, in this sequence, if we wanted to write an explicit formula, we'd say that the nth term is equal to the first term, in this case 2, plus the common difference 3 times n minus 1. And then if you want to distribute, you can write this one out as 3n minus 1. So those are some arithmetic sequences and how you would write recursive rules and explicit rules for them. Next up, we're going to talk about geometric sequences. All right, let's talk a little bit about geometric sequences. Geometric sequences are sequences that increase or decrease by a common ratio, which we call R for ratio. You can think of geometric sequences as being multiplication. So an example of a geometric sequence would be 2, 6, 18, 54, and so on. This is a sequence where the first term is 2, and then each term is 3 times the previous term. So the common ratio in this case is 3. Now, to write a recursive rule for a geometric sequence, you start with the first term, just like we did for arithmetic sequences or any sequence. Then we say for the nth term, you take the previous term and you multiply by the common ratio. So for example, if we wanted to write a recursive rule for this sequence, we would say the first term is 2, and then starting with the next term is equal to the previous term times 2. Times 3, which is the common ratio. So starting with the second term, we take the first term and multiply by 3. Then for the third term, we take the second term and multiply by 3, and so on and so forth. If we want to write an explicit rule for a geometric sequence, we say that the nth term is equal to the first term times the common ratio raised to the n minus 1 power. So for example, if we want to write an explicit rule for this sequence, we would say the nth term is equal to the first term, which is 2, times the common ratio raised to the n minus 1 power. Notice if you let n be 1, you plug in 1 for n, and you get that a sub 1 is equal to 2. If you let n be 2, plug in 2 for n, and you get that a sub 2 is equal to 6, and so on and so forth. Now, what I want you to do, go back to the first page, see if you can write both recursive and explicit rules for the sequences that are listed on the front page, then go through and see if you can fill in the remaining notes in this packet. Remember, a copy of my filled-in notes are on the Canvas website, so you can check as you go. I also promise I'll be back tomorrow, and I'll answer any questions that you have about any of this. And if you've lasted this long, you deserve a joke. What's an astronaut's favorite key on the keyboard? The space bar, of course. I know, that's a dumb one. Alright, thanks for watching. See you tomorrow.